In this recording, we're going to learn how to graph rational functions. So oftentimes rational functions will look something like this. They will have one or more curves that are bound by what are called asymptotes. And we're going to define vertical and horizontal asymptotes. Basically, an asymptote is a curve that a function approaches at its extremes. And it comes from the Greek word meaning not falling together. So it's kind of a weird spelling and a weird pronunciation. Again, it's asymptote. So a vertical asymptote is a line, a vertical line, like an x equals line. You can see we have one here. That the function to the left and to the right approaches either negative infinity, like it's doing down here, or positive infinity, like it's doing up here. So let's define that. Okay, so it's a line of the form x equals h, a constant, such that as x approaches h from the left, like as we're coming along and approaching this function from the left, this vertical line from the left, I shouldn't say function, or the right, coming along to the right, the graph, the y values of this rational function either approach negative infinity or approach positive infinity. And that's how we express it. F of x approaches infinity with this little arrow. Now let's define horizontal asymptote. Okay, so a horizontal asymptote will be of this form, kind of like this one here, y equals 0. So this line, y equals k in general, is a horizontal asymptote if f of x, the y values, approach k. So as we're getting close to that line in either direction, as x approaches positive or negative infinity. Okay, so we're going to graph one of these functions. We're going to describe its end behavior and its intermediate behavior and its horizontal and vertical asymptotes. So I'll give you a chance to write this down. Play the recording when you're ready. Okay, so what we're going to do is determine algebraically where the vertical asymptote is. So first we have to get this into the form of a rational function, right? F of x over g of x. So let's do that like we did previously. We're going to multiply this side by x plus 3 over x plus 3. Okay, so now we can combine Okay, so we've created here a rational function. And now we have to determine where is the vertical asymptote. Well, that's going to be the place where x would cause this fraction to be undefined, right? So the value of negative 3 is going to cause this to be undefined. So let's set that up. So therefore, x equals negative 3 is our vertical asymptote. Okay. So at this point, let's head over to our graphing calculator if you have one. If you don't have one, you could use Desmos. And let's enter our transformed function into the y equals. So we'll go x plus 2 over x plus 3. All right. One thing we can do is check our table for the vertical asymptote. So we can peek at table. We're down in the 330s. All right, so let's set up our table set to start at 0 and go by ones. Now we can check our table. And if we look here, there's going to be an error at x equals -3, which means we have a vertical asymptote there, and that's what we thought. Now we can look at the graph. So we're going to set up our axes. We can start with a zoom 6. That would be a standard window. And then maybe we can zoom in on this portion of it a little bit, right around the asymptote. So let's create a window that goes from -4 to 4 in both directions. Now when we hit graph, we're going to be a little closer in on that function. Okay. I think actually I'd like to see it out a little bit more there. I'm going to go x min of -6. All right, that's nicer. Okay, so let's make a graph of that on our paper. So we'll set up an axis. Okay, once we've got that set up, we can sketch in what we saw in terms of the vertical asymptote. Represent that with a dotted line. And then the question is, where was our horizontal asymptote? So we'll label that vertical. Where was our horizontal asymptote? Well, looks like it's right in here. Looks like it's getting close to x equals 1. We could confirm that algebraically later on. We're going to learn more about that, but let's just check out the table to see if that makes any sense. As we get bigger and bigger values of x, are we getting closer and closer to x equals 1? And it looks like this is really getting very close to 1, right? Now let's go in the negative direction. We'll set up our table at -30, say, and peek at our table. And are these values also getting closer to 1? Yes. They're very close to 1. 35 over 34 keeps getting closer to being a 1. So we can make that sort of assumption, I guess, that yes, in fact, the horizontal asymptote is x equals 1. That does not show up readily on your calculator, but you can kind of figure it out by looking at the table, and we're going to have algebraic techniques later. So label both of those, please. And now you just have to draw where the x-intercept appears to be. So we'll go back here to our graph. It crosses the x-axis at -2. Does not appear to have, well, I guess the y-intercept is somewhere between 0 and 1. We could again look at the table for when x equals 0. And no surprise, it is 2/3. So we can plot that point as well. All right, so we got a x-intercept right about there. I'm sorry, y-intercept there, x-intercept there. Draw that curve out, and then we have this portion of the curve as well. Okay, so we have our vertical asymptote established, and now we just need to say what the intermediate behavior is near that asymptote. So the intermediate behavior is what's going on near that vertical asymptote. So as x approaches -3 from the left, and the way we represent from the left is just with a little negative sign, from the more negative numbers. What is f of x doing? Well, f of x is getting a lot closer to positive infinity. And then conversely, as x approaches -3 from the right, we put a little plus sign, f of x Well, let's check that out. As we go towards -3 from the right side, f of x goes and approaches -infinity. Okay, so that's our intermediate behavior. Okay, so because we have that, therefore, x equals -3 is a vertical asymptote by our definition. Okay, let's go a little further and figure out the end behavior. So your end behavior is what happens out at the extremes, at the ends. And what we say is, as x approaches -infinity, and then as x approaches +infinity. So what's y doing at those points? So as we get way out there, we looked at that in the table, and we saw that in fact f of x approaches 1 in both cases. And therefore, y equals 1 is the horizontal asymptote by our definition. You might ask, why did I use the for the horizontal and a for the vertical? No particular reason. We can make it the in both cases. So you're going to use a combination of algebraic and graphical methods as well as numeric, looking at the table, to make these determinations. Thanks for watching.